For this last example, we are asked to use Gauss-Jordan elimination. It's just an extended version of Gauss elimination. The only difference is we want the left side of our augmented matrix to be the identity matrix. So first I need to put the first equation and the last equation in order because they are not. I need to have x, y, and z. So x, move the y over, move the z over. My second equation is just fine, x, y, and z. My third equation needs to be moved, 3x plus y, move the z over, equals 4. Now let's make our augmented matrix. Our augmented matrix, we list all the coefficients for x, 1, 1, 3. List the coefficients for y. 1, negative 1, 1. List the coefficients for z. 1, 2, 1. My separator line. And we list the constants. 2, 9, 4. I already have a 1 in this top corner, so I'm going to leave my first line alone. I need this 1 to become a 0, so I'm going to do negative 1 times row 1 added to row 2. So negative 1 times row 1 will give me negative 1, negative 1, negative 1, negative 2. Row 2 is 1, negative 1, 2, 9. Add them up. And there's my new row 2. I also want this 3 to be 0, so I'm going to do negative 3 times row 1 plus row 3. I'm going to do these two in one step to make our process a little bit shorter. So negative 3 times row 1 will give me negative 3, negative 3, negative 3, negative 6. I list row 3 right beneath it. 3, 0, 3, 1, 1, 4. Combine them, so negative 3 and positive 3 is 0. Negative 3 plus 1 is negative 2. Negative 3 plus 1 is negative 2. And negative 6 plus 4 is 2. Negative 2. So there's my new row 3. So our new matrix, my first row, we did not manipulate it. So it is going to stay the same for now. My second row is 0, negative 2, right here. 1, 7. My third row, right here. 0, negative 2, negative 2, negative 2. Next, I go to my second column. This first one right here needs to become a 0 because I need the identity matrix, which has 1s in the main diagonal and 0s as the rest. So this 1 needs to become a 0. If I multiply this the second row by a half and I add it to this row, I can get rid of that 1, but I'll have a fraction because of that 7. If I multiply my third row by a half, there won't be any fractions. So I'm going to use the third row. So 1/2 of row 3 plus row 1 will give me the 0 I need right here. So half of row 3. Half of 0 is 0. Half of negative 2 is negative 1. Half of negative 2 is negative 1. And half of negative 2 is negative 1. Row 1. 1, 1, 1, 2. Combine them. 0 and 1 is 1. negative 1 and 1 is 0. Negative 1 and 1 is 0. Negative 1 and 2 is 1. Perfect. So my first row is going to be 1, 0, 0, 1. I have my first row completely done. These two zeros make it finished, so I'm not going to want to manipulate row 1 anymore. I don't want to change it at all. My next row, I need to have this negative 2 become a 1. So in order to do that, I'm going to take half of row 2. So half of row 2 will give me 0, sorry, negative half, 1, negative 1 half, and negative 7 halves. That's my new row 2. I just took half of everything. Again, don't worry about the fraction, it will go away. Now I need this last negative 2 right here to be a 0. Well, that's easy to do. If I just add these two together, one of them has to be negative, and I can make it go away. Just that easy. So what I'm going to do is I'm going to multiply row 2 by a negative, and I'm going to combine it to row 3. So negative 1 times row 2 plus row 3. This will give me my third row. So negative 1 times row 2 will give me 0, 2, negative 1, and negative 7. Row 3 right beneath it, 0, negative 2, negative 2, negative 2. Combine them. 0 and 0 is 0. 2 and negative 2 is 0. Negative 1 and negative 2 is negative 3. Negative 7 and negative 2 is negative 9. So my third row is 0, 0, negative 3, negative 9. Almost completely finished. I just need to make this 1 half become a 0 and this negative 3 become a 0. So I want to get rid of this 1 half. In order to get rid of it, I'm going to multiply my row 3 by a negative 2 over 6. Let's see if that works. Not 2 6, sorry, 1 6. So I'm going to multiply row 3 by a negative 1 6, and I'm going to add it to row 2. So 1 6 of row 3 will give me 0, 0. Negative 1 6 of 3 is 1 half. 1 6 of 9th, or 9, sorry, is 3 halves. And then row 2 right beneath it. And when I add them straight down, I get 0 and 0 is 0. 0 and 1 is 1. 1 half and negative half is 0. And 3 halves minus 7 halves is negative 2. That takes care of the 0 here. Now if I want to get rid of this negative 3, I'm just going to multiply by 1/3. So 1/3 of row 3 will give me 0, 0, 1, and negative third times 9 is 3. So our new matrix, let's use a different color, is 1, 0, 0, 1, 0, 1, 0, -2, 0, 0, 1, 3. This gives me my solution, 1, -2, 3. So 1x equals 1, 1y equals -2, and 1z equals 3.